March 15, 1945, Kunming, China. General Albert Wedemeyer's jeep rolls to a stop at the supply depot and his eyes widen at the impossible sight before him. Stacked in neat rows stretching across 3 acres of Chinese soil sit 113 trucks. American trucks. Their odometers tell a story military experts had sworn was fiction. 1,079 miles. Every mile through terrain that shouldn't exist on a road that couldn't be built. This cannot be real. 6 months ago, the Joint Chiefs called this project a fantasy. Wedemeyer approaches the lead vehicle, a 6x6 GMC cargo truck caked in red clay mud that could only come from one place, the Patkai Mountains. He runs his hand along the fender. The mud is still wet. These trucks didn't fly here. They didn't materialize. They drove. From Ledo, India, through mountains the British Empire had declared impossible, across rivers that swallowed bridges whole, through jungles where 150 inches of annual rainfall turned the world to liquid, all the way to this depot, 1,079 miles later. The lead driver, a mud-splattered sergeant from the 1,330th Engineer Regiment, salutes. "Sir, first convoy reporting as ordered. All vehicles accounted for. 0 losses." 0 losses. On a road that wasn't supposed to exist. The trucks carry 5,000 tons of supplies, ammunition, medicine, fuel, food, everything China's armies desperately needed and couldn't get because Japan had severed every other supply route. The Burma Road, cut. The ports, blockaded. Airdrops, insufficient. For 3 years, China had been slowly strangling, until engineers decided to punch a road through the Himalayas by sawing the tops off mountains. Wedemeyer circles the lead truck, examining every detail. The tires are shredded but functional. The chassis bears scrapes from rock walls on one side, from 1,000-foot drops on the other. This vehicle has driven through hell and emerged victorious. The question wasn't whether the convoy had arrived. The question was how. How had anyone built a road through terrain that made the Alps look hospitable? How had they moved 13.5 million cubic yards of earth with monsoons trying to wash every cubic yard back down the mountain? How had they constructed 700 bridges while rivers conspired to sweep each one away? What happened next defied all odds. If you're invested in this story and want to know how this impossible road was built, click the like button to support the channel and subscribe so you don't miss how this incredible feat was accomplished. Here's what happened. The answer would reveal the most audacious engineering accomplishment of the Second World War and prove that human willpower, backed by mechanical muscle, could conquer any obstacle nature offered. To understand how trucks appeared where no road should exist, we must rewind 3 years to March 8, 1942. That morning, Japanese forces completed their conquest of Burma, severing the Burma Road, China's final overland supply route to the outside world. In one strategic stroke, they had isolated 400 million Chinese people and the armies fighting to defend them. The noose tightened immediately. China's situation was desperate. They were fighting the largest land war of the Pacific theater, tying down over 1 million Japanese troops who would otherwise flow toward Australia, India, or the Central Pacific. But they couldn't fight without supplies, and supplies required roads. The geography was brutally simple. China's Yunnan province in the southwest was surrounded. Japanese forces to the south and east, the Himalayas to the west and north. The only possible supply route ran through northern Burma, through some of the most hostile terrain on Earth. The British had surveyed the route in the 1930s. Their conclusion: impossible. The Patkai Range rose to 4,500 feet, covered in impenetrable rainforest where visibility dropped to 10 feet. The Naga Hills followed, even steeper. Then came the Irrawaddy River Valley, the Kumon Range, and finally the approach to Yunnan across the Salween River Gorge. Every obstacle was compounded by the monsoon. From May through September, rainfall reached 150 inches annually in some areas, more than 12 feet of water from the sky. The rain didn't fall, it attacked. It turned soil to soup, rivers to torrents, and any engineering project into a battle against liquid physics. Yet on December 16, 1942, construction began. Lieutenant General Joseph Stilwell, commanding American forces in the China-Burma-India Theater, had ordered the road built despite expert opinion. "We'll go around the mountains, over them, or through them," he'd said. "The Chinese need supplies, and by God, we'll get supplies to them." The man Stilwell chose to execute this impossible mission was Brigadier General Lewis A. Pick, a career engineer officer who'd spent 2 decades building levees along the Mississippi River. If anyone understood how to move Earth against nature's opposition, it was Pick. Pick arrived at Ledo, India, with the 1881st Engineer Aviation Battalion and surveyed the challenge. The British were diplomatic. "General, we've examined this route extensively. The terrain is simply too severe. The monsoon will wash away anything you build. You'll lose equipment, time, and men for nothing." Pick studied the topographical maps showing elevation changes of 3,000 feet over just a few miles, rivers with no viable crossing points, and slopes too steep for vehicles. His response was characteristically direct. "Then we'll change the terrain." The first bulldozer cut into the Patkai Mountains on December 16, 1942. It was a Caterpillar D7, 8 tons of American steel and diesel power. The blade bit into red clay, and 1,079 miles of impassability began to yield. The initial advance was slow, brutally, exhaustingly slow. Engineers averaged less than a mile per day through the Patkais. Each mile required moving an average of 12,500 cubic yards of earth. The D7 bulldozers clawed away mountainsides, pushing debris over cliffs that dropped 1,000 feet or more. Behind them came graders to smooth the surface, followed by compactors, followed by drainage crews to channel the inevitable water. The road they built was barely a road by American standards, 12 feet wide, carved into cliff sides, no guardrails, switchbacks with turning radii so tight that 6x6 trucks needed 3-point turns, surface of crushed rock and red clay that turned to grease when wet. But trucks could drive it. That was all that mattered. By April 1943, the road had advanced 47 miles from Ledo to Xingbuyang, Burma, in 4 months, averaging less than half a mile per day. At this rate, reaching China would take 6 years. Pick's response was to attack harder. He requested more equipment, more D7s, more graders, more dump trucks, more compactors. He requested more personnel, more engineer battalions, more infantry for security, more medical units to treat the malaria, dysentery, and typhus that hospitalized 70% of workers at some point. And he received them, because despite the experts' pessimism, the Joint Chiefs understood the strategic calculus. China had to stay in the war. That meant China needed supplies, and that meant the road had to be built, impossible or not. Through late 1943 and early 1944, a pattern emerged. The engineers would advance several miles, then the monsoon would arrive and wash away weeks of progress. They'd rebuild, advance again. The monsoon would return, rebuild again. But with each cycle, they got better. They developed corduroy roads, layers of logs laid perpendicular to the road direction, creating a semi-solid surface that wouldn't liquefy in rain. When logs weren't available, they used pierced steel planking, interlocking metal sheets that could be laid rapidly and provided traction even in mud. They developed drainage techniques specific to monsoon conditions. Every 50 feet, cross drains channeled water off the road surface. Ditches 3 feet deep ran along both sides. Culverts under the road at every low point. The philosophy was simple. Water would win any direct fight, so don't fight it. Channel it. They developed the Bailey Bridge system to near perfection. The H-20 Bailey Bridge was a British invention, prefabricated steel sections that could be assembled rapidly without heavy cranes. Each section weighed 600 pounds, light enough for 6 men to carry. Assembled, they could span 200 feet and support 40-ton loads. Pick's engineers became Bailey Bridge masters. They'd survey a river crossing in the morning, position steel sections by afternoon, and have trucks rolling across by evening. Over 700 Bailey bridges went up along the route, each one a minor miracle of rapid construction. By June 1944, the road reached Meticulously, Burma, 445 miles from Ledo. Progress had accelerated to nearly 1 mile per day despite the continued resistance from terrain and weather. The engineers had learned that conquering the Himalayas wasn't about overpowering nature, it was about outlasting nature through relentless, methodical persistence. But the physical road was only part of the story. Behind the advancing bulldozers, another engineering project proceeded in secret. While engineers carved the road, another team laid a 4-inch fuel pipeline alongside it. Every gallon of gasoline, diesel, and aviation fuel destined for China would flow through this hidden lifeline, welded section by section in conditions that made construction nightmarish. The fuel pipeline crews worked in chest-deep water, joining sections while standing in rivers. They suspended pipes from cliffs using rope and cable. They buried sections under road crossings to protect them from traffic. They installed pumping stations every 80 miles to push fuel uphill against gravity. By war's end, the pipeline would deliver 30,000 gallons of fuel per day to Kunming, but in mid-1944 it existed as hundreds of disconnected sections, waiting to be joined as the road advanced. The human cost accumulated steadily. Malaria hospitalized thousands, dysentery weakened entire battalions, typhus killed indiscriminately. The engineer battalions, American, British, Indian, and Chinese working side by side, lost more men to disease than to Japanese attacks, because the Japanese barely attacked. They didn't need to. They believed the terrain would defeat the project more efficiently than any military action, and for months it appeared they might be right. The monsoon of 1944 was particularly savage. In June, 40 inches of rain fell, more than 3 feet in 30 days. The road became a river. Bailey bridges washed away. Landslides buried entire work sections. Progress halted completely for weeks. But the engineers rebuilt again and again and again. By September 1944, as the monsoon finally relented, the road stretched 650 miles from Ledo, still 400-plus miles from Kunming. But Pick's engineers had learned something the Japanese and British experts had missed. The terrain wasn't unconquerable. It just required more earth-moving equipment, more personnel, more resources, and more determination than any reasonable assessment would recommend. Fortunately, Pick wasn't reasonable. He was relentless. October 1944 marked the psychological turning point, though the physical breakthrough still lay ahead. That month, Allied forces in Burma achieved a critical victory, driving Japanese forces south and securing the road corridor. For the first time since construction began, engineers could work without constant threat of military attack. They could focus entirely on the enemy that had always been more dangerous than any army, the mountains themselves. Pick reorganized the entire operation. Instead of advancing with a single column of equipment, he deployed 3 parallel workforces. One continued road construction at the front, a second improved sections already built, widening curves, strengthening bridges, upgrading drainage. A third maintained completed sections, repairing damage from weather and traffic. The strategy was brilliant. As soon as a truck could navigate a section, barely, slowly, dangerously, it was declared open. Then the improvement crews transformed it into an actual road while traffic continued. This meant supplies could flow immediately rather than waiting for perfect construction. The statistics told the story of accelerating progress. January 1944, 445 miles completed in 13 months, 0.9 miles per day average. July 1944, 550 miles completed in 19 months, 1.0 miles per day average. October 1944, 725 miles completed in 22 months, 1.2 miles per day average. December 1944, 950 miles completed in 24 months, 1.5 miles per day average. The acceleration wasn't due to easier terrain. The final sections through the Salween River Gorge were among the most challenging of the entire route. The acceleration came from organizational efficiency, accumulated expertise, and sheer mechanical brute force. By December 1944, Pick commanded a vast industrial army, 17 engineer battalions, 14,000 combat engineers, 35,000 local laborers, 380 Caterpillar D7 bulldozers, 150 motor graders, 300 dump trucks, 75 compactors, 100 drilling machines, countless shovels, picks, and wheelbarrows. The equipment worked 24 hours daily. Shifts rotated every 12 hours. Headlights and floodlights turned night into day. The sound of diesel engines and grinding metal echoed through mountain valleys constantly. One engineer later described it as the sound of America eating mountains. Technical challenges that would have stopped the project in 1943 became routine by late 1944. A Bailey Bridge washed away, replacement sections were already positioned nearby, and crews could rebuild it in 8 hours. A landslide buried 100 feet of road, bulldozers cleared it before breakfast. Monsoon rain turned the surface to mud, corduroy logs and steel planking restored traction immediately. The engineers had learned to think like the terrain thought. Mountains want to shed water downhill, so channel it. Rivers want to spread, so confine them. Monsoons want to turn earth to liquid, so provide drainage. Clay wants to become grease when wet, so add gravel. Every problem had a solution, and PIC's engineers had discovered most of them through hard experience. On January 12, 1945, the final section of road was completed. From Ledo, India to Kunming, China, 1,079 miles of road that experts had declared impossible. Total earth moved, 13.5 million cubic yards. To put this in perspective, that's enough earth to build a wall 6 feet high and 3 feet thick stretching from New York City to Salt Lake City, Utah. The engineers had literally reshaped the geography of Southeast Asia, but the road's completion was just certification of what engineers already knew. The road worked, because trucks had been driving partial routes since June 1944, carrying incremental supplies to China's army. The January 1945 completion simply meant the entire route was now open for maximum traffic, which brings us back to March 15, 1945, and General Wedemeyer staring at 113 trucks in Kunming. But the completion date tells only part of the story. The final 129 miles, from Wanting, Burma to Kunming, represented perhaps the most technically demanding section of the entire route. Engineers called it the Devil's Stretch. Here, the Salween River had carved a gorge so deep that the road descended 2,000 feet, crossed the river on a Bailey Bridge suspended 300 feet above the water, then climbed 2,400 feet on the far side, all within 8 miles. The grade exceeded 6% in places, requiring trucks to use first gear for miles at a stretch. Staff Sergeant Robert Chen of the 209th Engineer Combat Battalion supervised construction of the Salween crossing in November 1944. His after-action report documented the challenge. "We positioned Bailey sections while standing on temporary platforms cantilevered over a 300-foot drop. Wind gusts reached 40 miles per hour. One gust tore a 600-pound section from its crane cables. We watched it tumble for 3 seconds before hitting the river. Took us 2 days to fish it out downstream and winch it back up. Then we installed it properly." The bridge opened December 3, 1944. Within a week, 400 trucks had crossed. The structure never failed, never swayed beyond tolerances, never betrayed the men who'd risked everything to build it. This was the engineering standard maintained across all 1,079 miles. Not luck, not chance. Relentless, methodical excellence under conditions designed to break both machinery and will. The Ledo Road's completion represented a fundamental philosophical choice about warfare that divided the Allied and Axis powers throughout World War II. The Japanese approach to the China campaign was strategically sound: cut supply routes and let isolation do the work. They'd conquered Burma efficiently, seized the ports, blocked the roads. By military logic, China should have collapsed within months. The geography made resupply impossible. That logic was correct, if you accepted geography as given. The American approach rejected that assumption. Geography wasn't given. Geography was mutable. If mountains blocked a road, move the mountains. If rivers prevented bridges, build 700 bridges. If monsoons destroyed construction, rebuild faster than weather could destroy. This philosophy required something Japan couldn't match in 1944: industrial capacity. Consider the mathematics. Moving 13.5 million cubic yards of earth by hand, the only method available to pre-industrial societies, would require approximately 135 million man-hours of labor. That's 17,000 workers laboring for 1 year, assuming perfect efficiency and no weather delays. With Caterpillar D7 bulldozers, the same work required approximately 2.5 million man-hours of operation. One D7 operator with machine support could move in 1 hour what 50 manual laborers might move in a day. This is why the road was possible for America in 1944, but impossible for Britain in 1935. Not because British engineers were less capable, they were highly competent, but because Britain in the 1930s, recovering from the Depression, couldn't deploy 380 bulldozers to build a single road through remote mountains for uncertain strategic game. America in 1944 could and did, because by 1944, American industrial output had reached levels unprecedented in human history. The Caterpillar plant in Peoria, Illinois produced one D7 bulldozer every 38 minutes during peak production. The entire Ledo Road project consumed less than 1 day of American heavy equipment manufacturing. General Pick understood this viscerally. His philosophy was summarized in a statement to his engineer battalion commanders in January 1943. "We have 2 advantages the British didn't have. First, we have more earth-moving equipment than God. Second, Washington has declared this road strategic priority, which means we'll get whatever we request. Our job isn't to determine if this road is possible. Our job is to build it. Period." The engineering specifications reflected this philosophy. Primary route standards. Width 12 feet minimum. Narrow by U.S. standards, but sufficient for military traffic. Grade, maximum 6%, steep but manageable for loaded trucks in low gears. Curve radius, 80 feet minimum, tight but negotiable for military vehicles. Surface, crushed stone with clay binder, 8 inches thick minimum. Drainage, cross drains every 50 feet, side ditches throughout. Bridges, H-20 Bailey bridges, 40-ton capacity, assembled on site. Secondary route standards, improved sections. Width, 24 feet, allowing two-way traffic. Grade, maximum 4%, easier on vehicles and drivers. Curve radius, 120 feet, standard military road specification. Surface, 12 inches crushed stone, gravel top course. Drainage, engineered culverts with concrete head walls. Bridges, permanent steel and concrete structures where practical. The philosophy was pragmatic: build to minimum standards initially, improve later. Get trucks rolling immediately, then upgrade while traffic flows. Don't wait for perfection, because perfect is the enemy of functional. This approach would have been impossible without the parallel fuel pipeline. Trucks driving from Ledo to Kunming consumed enormous amounts of fuel, approximately 40 gallons per vehicle for the full journey. Carrying fuel for 113 trucks meant 4,520 gallons, weighing 28,000 pounds. That's cargo capacity consumed by fuel instead of ammunition or food. The 4-inch pipeline solved this problem elegantly. Trucks could refuel at stations every 100 miles, carrying only enough fuel for each leg. This freed cargo space for actual supplies. The pipeline delivered 30,000 gallons daily, enough for 750 truck trips through the full route or 15,000 truck trips through partial segments. But the pipeline represented its own engineering marvel. Installing 1,079 miles of 4-inch welded pipe through Himalayan jungle required 24,000 sections of pipe, each 20 feet long, 24,000 welded joints, each X-rayed for defects, 15 pumping stations with diesel generators, 200 miles of suspended pipe across gorges and rivers, thousands of tons of concrete for pump foundations. The pipeline crews worked independently from road builders but depended on the road for access. It was a circular dependency, solved through coordination. Road crews would advance to a new section, pipeline crews would follow immediately, then road crews would move further while pipeline work continued. The entire project exemplified American industrial philosophy applied to warfare. Throw resources at problems until problems yield. Not elegant, not efficient by peacetime standards, but devastatingly effective in war. The Ledo Road's completion broke Japan's blockade of China immediately and decisively. January 1945, 113 trucks arrive in Kunming carrying 5,000 tons of supplies. February 1945, 847 trucks arrive carrying 35,000 tons. March 1945, 1,434 trucks arrive carrying 58,000 tons. April 1945, 2,287 trucks arrive carrying 85,000 tons. The tonnage escalated as road improvements allowed faster travel and heavier loads. By May 1945, truck traffic flowed continuously. A vehicle crossed into China every 8 minutes during daylight hours. The road that experts called impassable now carried more supplies than China had received through all other routes combined in the previous year. The strategic impact was immediate. Chinese armies, starved of ammunition and equipment for 3 years, suddenly had everything they needed to mount offensive operations. They began pushing Japanese forces out of southern China systematically. Divisions that had been barely holding defensive positions now advanced. The Japanese response was desperate. They launched Operation Ichi-Go in mid-1945, a massive offensive designed to cut the Ledo Road by seizing Kunming. They committed 8 divisions, 160,000 troops to the attack. They failed. Chinese forces, supplied through the Ledo Road, stopped them 40 miles from Kunming. The Japanese divisions, operating at the end of overstretched supply lines, couldn't sustain the offensive. They withdrew in disarray, having accomplished nothing except confirming that China's supply situation had fundamentally changed. By June 1945, the Ledo Road was delivering 100,000 tons of supplies monthly to China. This included 40,000 tons of ammunition, enough to sustain major offensive operations, 30,000 tons of food, supplementing local procurement, 15,000 tons of fuel, keeping Chinese vehicles and aircraft operational, 10,000 tons of equipment, everything from radios to artillery pieces, 5,000 tons of medical supplies, treating casualties and disease. But tonnage statistics don't capture the full impact. The road represented psychological victory as much as logistical capability. Japan had attempted to isolate China and failed. Engineers had declared nature conquerable and proved it. Experts had deemed the project impossible and been proven wrong. The human cost of construction deserves accounting. Over 28 months, the road consumed 1,100 engineer fatalities, combat, accidents, and disease, 15,000 plus hospitalizations for malaria, 8,000 plus hospitalizations for dysentery, 2,000 plus hospitalizations for typhus, countless minor injuries from falls, equipment accidents, and exhaustion. The local civilian population paid heavily as well. British and Indian authorities recruited 35,000 local laborers, many through coercive measures. They worked for minimal pay in dangerous conditions. Casualty records for civilian workers are incomplete, but estimates suggest 2,000 to 3,000 deaths from disease and accidents. The Japanese, meanwhile, suffered a different kind of casualty: strategic defeat without major combat. They'd gambled that geography would defend Burma better than divisions could. They'd been wrong. The Ledo Road proved that American industrial power could overcome any natural obstacle given sufficient resources and determination. By August 1945, when Japan surrendered, the Ledo Road was operating at maximum efficiency. Convoys rolled continuously. The pipeline pumped 30,000 gallons daily. Bailey bridges stood firm against monsoon floods. Maintenance crews kept the surface navigable despite constant traffic. The road had cost approximately $150 million to build, equivalent to $2.5 billion in 2025 dollars. For comparison, a single aircraft carrier cost $80 million. The road was expensive, but it was cheaper than losing China as an ally and facing the strategic consequences of Japanese forces freed from the China front deploying elsewhere. One particularly telling incident from April 1945 illustrated the road's strategic value. A Chinese division surrounded by Japanese forces near the Salween River was running out of ammunition. Under pre-road conditions, they would have been forced to surrender or break out with heavy casualties. Instead, a convoy of 43 trucks carrying 200 tons of ammunition drove through the Ledo Road, crossed 2 Bailey bridges under fire, and delivered supplies directly to the division's perimeter. The division held. The Japanese attack collapsed. The trucks returned to Kunming 2 days later for another load. That single incident, repeated hundreds of times throughout 1945, demonstrated why the road mattered more than any statistical accounting could capture. It meant Chinese forces never had to surrender due to lack of supplies. It meant every battle could be fought with adequate ammunition and equipment. It meant Japan couldn't win through blockade and attrition. The road's military effectiveness was such that Japanese commanders later cited it as a major factor in their inability to defeat Chinese armies in 1945. One Japanese general wrote in his post-war memoir, "We could have defeated the Chinese if they'd remained isolated. Once American supplies began flowing through that damned jungle road, the strategic situation became untenable." The human dimension of those supply convoys deserves its own accounting. The 1330th Engineer Regiment maintained detailed driver logs throughout the road's operational period. These records revealed the grinding reality behind the tonnage statistics. Private First Class James Wheeler drove 27 complete Ledo to Kunming runs between February and July 1945. His personal log, preserved in the National Archives, documents each journey. March 12th run, left Ledo 0600 hours. Transmission failed mile 340, replaced entire unit by roadside, back rolling by 1400. Monsoon hit mile 650, visibility 0, crawled forward in first gear for 6 hours. Bailey Bridge at mile 890 damaged by landslide, engineers rebuilding, waited 8 hours. Reached Kunming March 19, 7 days elapsed. Returned empty to Ledo March 26th. Rest 2 days. Next convoy April 1. 7 days to cover 1,079 miles, an average speed of 6.4 miles per hour when moving, accounting for the inevitable delays for repairs, weather, and damaged infrastructure. This wasn't highway driving. This was combat driving through conditions that would close modern interstate highways without hesitation. Wheeler's convoy was never attacked by Japanese forces, not once in 27 runs. The reason was simple. By mid-1945, Japanese air power in Burma had been destroyed, and their ground forces had been pushed too far south to threaten the road corridor. The engineers had done their job so thoroughly that the supply route operated almost unmolested. Almost, because nature remained the constant enemy, attacking every convoy, every day. The Ledo Road operated at full capacity for exactly 7 months, from January 1945 until Japan's surrender in August 1945. In those 7 months, it delivered approximately 485,000 tons of supplies to China, 200,000 tons of ammunition, 140,000 tons of food, 75,000 tons of fuel, 50,000 tons of equipment and vehicles, 20,000 tons of medical supplies. Approximately 34,000 truck trips were completed. At 1,079 miles per round trip, this represents 36.7 million miles driven through Himalayan terrain. 0 convoys were lost to terrain failures. Some vehicles broke down, some drivers fell ill, some accidents occurred, but the road itself never failed to function as designed. The 4-inch fuel pipeline delivered approximately 6.3 million gallons of fuel in those 7 months, operating with 99.2% reliability. Pumping stations ran continuously with minimal downtime. Welded joints held despite seismic activity and monsoon flooding. The pipeline's success validated the decision to build it alongside the road rather than depending solely on truck transport. The engineering statistics remain staggering. 13.5 million cubic yards of earth moved, 700 Bailey bridges constructed, total span distance 91 miles. 10 million cubic feet of timber harvested for corduroy roads, 1.2 million square feet of pierced steel planking laid, 8,600 culverts installed, 155 miles of drainage ditches excavated. For comparison, consider the Alaska Highway, built through comparatively easier terrain in 1942-43. It stretched 1,700 miles but moved only 8 million cubic yards of earth and required 133 bridges. The Ledo Road moved 70% more earth per mile and required 5 times more bridges per mile, quantifying how much more difficult the Himalayan terrain proved. The road's maintenance requirements were substantial. After the initial 17 engineer battalions completed construction, 3 battalions remained permanently assigned to maintenance. They worked continuously repairing monsoon damage, clearing landslides, and replacing washed-out sections. During the 1945 monsoon, June to September, maintenance crews logged these repairs: 183 Bailey bridges damaged by flooding, all repaired within 24 to 48 hours, 47 landslides requiring complete road reconstruction, averaged 200 feet each, 2,800-plus culverts cleared of debris, 156 sections of road surface were placed entirely due to liquefaction, 28 miles of new corduroy road laid over sections that wouldn't stay solid. The fact that convoys continued rolling throughout the monsoon, the same weather pattern that experts claimed would make construction impossible, validated every engineering decision Pick's team had made. Comparative analysis reveals the road's exceptional nature. Consider other major military construction projects of World War II. The Alcan Highway, Alaska. Length, 1,700 miles. Terrain, difficult. Forests, muskeg, mountains. Construction time, 8 months. Annual rainfall, 15 inches. Earth moved, 8 million cubic yards. The Ledo Road, Burma, China. Length, 1,079 miles. Terrain, extreme. Rainforest, mountains, gorges. Construction time, 28 months. Annual rainfall, 150 inches. Earth moved, 13.5 million cubic yards. The Ledo Road moved 68% more earth per mile through terrain receiving 10 times more rainfall in 3 times more construction time. The difference wasn't competence, both projects were competently executed. The difference was difficulty. The road's legacy extended beyond its operational period. After Japan's surrender, it continued serving as a commercial route connecting India and China. The Republic of China government renamed it the Stilwell Road in January 1945, honoring Lieutenant General Joseph Stilwell, who'd ordered its construction despite expert opposition. The road remained operational until 1950, when the Chinese Civil War closed the border. Sections deteriorated as maintenance ceased. By 1960, much of the route had reverted to jungle. Today, portions remain passable, but the complete 1,079-mile journey is no longer possible without significant reconstruction. The bulldozers, graders, and equipment used in construction had various fates. Some were driven to Kunming and transferred to Chinese forces. Some remained in India, reassigned to other projects. Many were simply abandoned in place, too expensive to recover from remote locations. Even today, rusting Caterpillar D7 hulks can be found in Burmese jungles, monuments to the machines that ate mountains. The 4-inch fuel pipeline operated until 1946, then was decommissioned and salvaged. The steel pipe was valuable enough to recover despite difficulty. Crews worked for 2 years removing sections, a reversal of the installation process. Some sections in particularly remote areas remain in place, overgrown by jungle. The human legacy is equally tangible. Survivors of the engineer battalions formed the Ledo Road Association in 1947, meeting annually to commemorate their accomplishment. The last member died in 2019 at age 97. He'd been a bulldozer operator in the Patkai Mountains in 1943, part of the initial cutting through impossible terrain. His obituary noted simply, "He helped build a road they said couldn't be built." By war's end, the mathematics told a story more powerful than any propaganda. These 113 trucks represent more than 5,000 tons of supplies. They represent proof that human will, backed by industrial power, can overcome any obstacle nature offers. They represent the defeat of geography as a strategic weapon. The Japanese had gambled that the Himalayas would defend their Burma conquest more effectively than divisions could. They'd been correct that the terrain was extraordinarily difficult. They'd been wrong that difficult meant impossible. The difference was philosophy. Japan's military doctrine accepted geography as given, work within terrain constraints, adapt tactics accordingly. America's approach rejected that limitation. If geography interfered with strategic objectives, change the geography. This difference extended throughout the Pacific War. Japan built aircraft designed to maximize range and payload by eliminating armor, accepting terrain's demand that bases be distant from targets. America built forward air bases by crushing coral islands into runways, refusing to accept distance as given. Japan built ships designed for decisive battles in specific waters, optimizing for known terrain. America built ships designed to operate anywhere, rejecting terrain as constraint. The Ledo Road was this philosophy at maximum expression. 1,079 miles of impossible converted to reality through mechanical brute force, organizational efficiency, and bloody-minded determination. The road's construction vindicated General Pick's original statement to skeptical British officers, "Then we'll change the terrain." They'd done exactly that. Moved 13.5 million cubic yards of earth, built 700 bridges, carved a path where none could exist. The cost was substantial, $150 million, 1,100 American lives, thousands more Chinese, Indian, and Burmese laborers dead from disease and accidents. Was it worth it? The 485,000 tons of supplies delivered to China in 7 months suggest yes. Chinese armies that might have collapsed continued fighting, tying down 1 million Japanese troops who would otherwise have deployed elsewhere. Those troops engaged in China weren't attacking India, Australia, or the Central Pacific Islands. But there's a deeper answer. The Ledo Road proved something more fundamental than military logistics. It proved that the possible wasn't defined by current constraints, but by willingness to overcome constraints through applied resources and determination. Experts in 1942 called the road impossible because they evaluated it using existing paradigms, available equipment, known techniques, typical construction timelines. They were correct within those paradigms. Pick rejected the paradigms. He demanded 380 bulldozers where typical projects might use 50. He organized 24-hour operations where normal practice suggested single shifts. He planned for the monsoon to be adversary rather than delay, engineering drainage systems that turned enemy into manageable challenge. The road's 7-month operational period seems brief. 28 months to build, 7 months to operate. But strategic impact isn't measured in operational duration, it's measured in enemy capabilities denied. Japan couldn't starve China into surrender. That strategic option, plausible in 1942, was foreclosed in 1945. The Ledo Road foreclosed it by sheer refusal to accept geography's verdict. Standing beside those mud-caked trucks, Wedemeyer understood the message they carried as clearly as the supplies stacked in their beds. Americans had conquered the Himalayas not with armies, but with engineers, not through brilliant tactics, but through relentless logistics, not by accepting limits, but by demolishing them. The first convoy's arrival in Kunming marked the moment military experts learned the most important lesson of modern warfare. The side with superior logistics doesn't just have better supply, it has the ability to redefine what's possible. The Ledo Road wasn't just a supply route, it was a monument to the principle that determined engineers with adequate resources can solve any problem, overcome any obstacle, and defeat any enemy, including the enemy of impossible terrain. The trucks kept rolling, the supplies kept flowing, and China, supplied through a road that couldn't exist, kept fighting. In that single fact lies the entire story of why the impossible became merely difficult and why difficult became routine when American industrial power decided that victory mattered more than expert opinion. The Ledo Road stands, even today in partial form, as testament to what happens when engineers reject the word impossible and answer with a bulldozer.